Hey, what's up? Welcome back. Before I start the podcast, I'd like to remind you that this podcast is also available on Spotify, Google Podcast, or wherever you listen to the podcast. To begin with, for you to be here now, trillions of drifting atoms had somehow to assemble in an intricate and curiously obliging manner to create you. It's an arrangement so specialized that it has never been tried before and will only exist this once. For the next many years, we hope these tiny particles will uncomplainingly engage in all the cooperative efforts necessary to keep you intact and let you experience the supremely agreeable but generally underappreciated state known as existence. Funny part is, why atoms take this trouble is a bit of a puzzle. Being you is not a gratifying experience at the atomic level. For all their devoted attention, your atoms don't actually care about you. Don't even know that you are there. To be more precise, they don't even know that they are there. They are just mindless particles after all, and not even themselves alive. Yet somehow, for a period of your existence, they will answer to a single rigid impulse to keep you, you. The atoms that so liberally and congenially flock together to form living things on Earth are exactly the same atoms that decline to do it elsewhere. Whatever else it may be, at the level of chemistry, these are nothing but the carbon, hydrogen, oxygen, nitrogen, a little amount of calcium, a dash of sulfur, a light testing of very other ordinary elements. And that's all you need. The only thing special about the atoms that make you is that they make you. And that is, of course, the miracle of life. So the question arises whether or not atoms make life in other corners of the universe. Yup, they make plenty else. Indeed, they make everything else. Without them, there would be no water or air or rocks, no stars and planets, no distant gassy clouds or swirling nebulae, or any of the other things that make the universe so agreeable material. Atoms are so numerous and necessary that we easily overlook that they needn't actually exist at all. There is no law that requires the universe to fill itself with small particles of matter or to produce light and gravity and other properties on which our existence hinges. There needn't actually be a universe at all. For a very long time, that wasn't. There was no atoms, no universe for them to float about in. There was nothing. Nothing at all, anywhere. So thank goodness for atoms. But the fact that you have atoms and that they assembled in such a willing manner is only a part of what you got here. To be here now, alive in the 21st century and smart enough to know it, you also had to be a beneficiary of an extraordinary string of biological good fortune. Survival on Earth is surprisingly a tricky business, thanks to the inventions and innovations of Homo sapiens. As I said earlier, atoms make up everything there is. They are the tiniest possible piece of matter and are found in everything. They even measured in picometers, okay? From this one elemental piece of primary matter, all gases, solids, liquid, and even light comes into existence. This understanding of the world was first expressed by ancient Greek philosopher Democritus. According to Democritus, the qualities of various types of atoms differentiated by shape, weight, or size, explain the different properties that could be observed in different states of matter. Democritus based his notions of atomic theory almost purely on speculation, as he had no way of observing atomic phenomena. Similar ideas about atoms also arose in India around the same time, though it was Democritus who came up with the term atom. However, it was not until the late 18th and early 19th century that scientific advances allowed researchers such as John Dalton to test Democritus' atomic theory. The work of subsequent scientists led to the contemporary understanding of atoms, their contemporary parts, and subatomic particles. Even though atomic theory began as little more than a philosophical musing, it eventually became a foundational concept of modern science. Not only did atomic theory allow for quantitative empirical measurements of matter, it allowed researchers to make and test prediction based on their understanding of how matter was composed at the very fundamental level, enabling the development of both theoretical and practical scientific application hand in hand.